Okay, so today we are going to talk about functional decomposition. This seems like a handful of a term, the functional decomposition. Okay, but it is pretty simple if you know what it gives you, the output, what this process gives you, then this becomes pretty simple. Functional decomposition is one of the concept development methods which is useful for product design, product development, and engineering design students. Okay, this can be one of your core subjects if you are doing bachelor's in product design or engineering design, or it can be one of the courses which is being taught to you. So if you are developing any new product, the first thing you are going to do is learn how to develop or how to sketch new concepts if you are given a problem statement. Okay, so there is a basic process. So if you are, so this is a systematic method by which you are going to get a concept as the output. Okay, there can be the concept development based on your intuition. That is, let's say you are given a problem statement that you have to design a coffee maker. Okay, here, so this will be faster if I show you here itself. So this is the second level. The first very basic level is this manual one. You can see this is the sketch for that. Okay, so one method is your intuition. That is, you see, that is, browse the internet for what a coffee maker looks like. Okay, these are few designs of the coffee maker. This somebody has collected these ideas. This is one design. This looks pretty different, and some futuristic ones could be this one. Okay, this is semi-futuristic as far as I can tell. Futuristic ones will be very, very abstract. Okay, very, very new. All of these we have seen, not this one though. This one is pretty common now. Okay, and this is what I have in the office. This is where the functional decomposition looks like. This is a method where you are following a system of thoughts. You're following a framework where you're going to get the concepts as the output. Okay, so functional decomposition, the first, obviously, if you have been asked to design a coffee maker, the first thing is what you're going to think is that you'll have to design a device which will create X, and this X is your coffee. Okay, so obviously you will have to get the coffee from somewhere, and then here, since you have to design a hot coffee beverage machine, you will need to mix coffee with the water, and then you're going to heat this mixture, or just heat the water and pull the water through the coffee. Okay, so this is the basic representation. This one is pretty basic, and this one is slightly more colorful drawing of a coffee maker. This is the reference if you're going to if you're looking for a reference, you can just search this one and go to that reference and then find those list of functions. Once we know what are the list of functions, we can then go to a function structure, that is how these functions are going to be arranged, at what stage what needs to be fed into the system to get our output. Okay, so let's just see this video. You can see the title and everything. Okay, so at this stage this is a grinder which is being fed the coffee beans, and then this passage is taking the ground coffee beans out. And then you can see this is a piston arrangement where the ground coffee beans are being fed, and sort of a pallet is being created. Now this will be tightly pegged, and then water is going to be pulled through this. This is the water container and the pump setup. Now this looks like the pump and piston arrangement, wherein the hot water is being fed. Okay, then the waste pellet is thrown out, and now we are getting the extract out, and this is being poured out. This looks like it's showing how the milk is getting heated, okay, using steam, and then the milk gets out. So here you can get what are the overall components of a machine. So by doing all of this research, what are the existing products, you can find out what are the components which the machine has. Okay, and also getting familiar with what the machine looks like and what are the internal mechanism and concepts and the components. Okay, so getting familiar with what you are going to create is really helpful. So then you can have your own version of how you want to get things done. Let's set out to create a machine something like this. So this is the basic machine at which the water sort of percolates or drips through the coffee beans. Okay, this is a simpler method. This is a non-pressurized gravity fed sort of system. Okay, so at the back you have the water container, and when you switch on your coffee, all it does is it switches on the heating pad which starts heating the water. This has a one-way valve, so only the water can so the way the gravity fed system works is that the level here this level is going to be same as the level of the water. Okay, so when the water in the reservoir or the container gets at this level, you know that the water stays at the same level. If in some way the reservoir is connected, okay, then the water will stay at the same level. If you fill water in a tube, okay, then because both of these ends are exposed to atmosphere, equal pressure is being applied at both of the ends, and because of this both the levels are going to be different. This is called water level and is being used at many engineering applications. Okay, so since the water is already present here, this is connected, the tube is connected to the reservoir, and since both the levels are same, when heat is being applied to the tube, the vapor gets out and sort of a pressure is created, and that pressure forces the liquid out. The steam is being forced out. Okay, and the water, that is the heated water, gets forced out and is fed through this cup, that is the filtered. This is sort of a filter which does not let the solid particles into the mug. Okay, so this is a method, this is a sort of a brewing method of the coffee, a simpler method. Okay, the schematic is shown here. This is slightly more easier to understand here. All right. Okay, so let's focus on this simple schematic. So in this case, as you can see here, the heated water will travel through this tube and up, right? So this is how the water gets up and it's going to percolate down. Okay, and you can see why there is this shape. Why is this shape here? Why is the tube given this shape, and why is it placed here? It is because you want to heat and you want this mug to be heated as well. Okay, so if it has milk in it, then that milk also will be heated, and this will be kept heated, ready to be consumed. Okay, this is your coffee container. We can call this coffee container. Okay, it's misbehaving. Coffee container. This is your water container. Okay, and this is your heating coil. All right, so this is a mental model. Okay, we have this model in our mind. So by doing all of this research, that is when you're given a problem statement, you have to get familiar with the problem. Okay, this is also called empathy mapping. That is, we empathize with the user, to whomever to whoever we are designing this for. Okay, so we have to know all of their pain points, that is, what are the problem they face. So all of this can be done by these days it's easier to just browse the internet, but unless you have used that product yourself, and unless you get the feedback of the people who have used this product, you cannot really know what are the pain points of these users, and you will not be able to design a good product. Best method is to just buy the product, if you're designing this professionally, or if you're designing as an academic project, you should first thing get a coffee maker or the product whatever you are designing for, buy the product and try to find out more about that product, that is, open the product up, use it and find what are the pain points. Okay, so in buying the product, it will also help you to get yourself familiar with one more concept development method, which is called reverse engineering. List of functions, or you can also call this in more technical term as functional decomposition, that is this one. Okay, functional decomposition. So one of your function, that is the primary function, is produce hot coffee, that is make hot coffee. Okay, this is our primary function. Now, in order to make hot coffee, you will have a list of sub functions. So let's call this function number 1. Okay, just to be safe, this is our function 1. Then in order to make hot coffee, we are already familiar that we need water, we need coffee, and then we need heat. Okay, these three things are needed. So our sub function, that is 1.1, okay, will be contain water. Okay, contain water. Your second function, that is 1.2, this function is contain coffee. And your third function, sub function, here 3, is contain coffee. You have one more function, that is 4, is user input. That is, the coffee cannot just go on producing coffee, that is, the machine cannot go on producing coffee whenever it wants. So so this should be user controllable. So at the very least we need a switch which looks like this one, using which the machine can be controlled. So we have to go down to all of this, since we are following a systematic approach. We need to write all of these things down. Okay, some of these may feel very obvious, but later down that stage all of these will be useful. Each of these will have a benefit or its contribution into our functional decomposition and then the concept. That is, nothing will be missed out. Okay, one of the good things about following a systematic approach is that things are not missed out. Let's take all of this numbering off away. Okay, what I can do is name this, that is contain water hot, as function number 1. Function number 2 can be contain coffee. Function number 3 can be, this needs to be taken off, and even this can be taken off. Let's name this as, this is containing coffee, and then we can name this as hold the cup, as function 3, because we need to place this cup somewhere, and the machine should allow for that, and this cup also is to be heated. Okay, that is hold the cup. Function 4 can be our user input, so we can move our user input here. This is our 4. So all of these are things to be achieved, and for which you will have to provide something physical or some code to satisfy this feature or function. Okay, so this was our main function, that is, and to satisfy that, this is our function, make hot coffee. This is our main function, contain hot water. Now our 1.1 here can be heating water. Okay, so this is our sub function. Then our second sub function can be carry the water to the coffee container. Okay, carry water or transport water, you can just call it transport water. Okay, now here we are. And the next function is contain the coffee. Okay, so the 2.1, so this can be the heading, and these can be these subheadings, and that is the subtasks. So this is, again, this can be regarded as one of the function. Okay, one function is this, second function is 2.1. Okay, we don't have to provide a separate heading which is different than these subtasks. So whatever works here, that is, whatever works well. So contain the coffee is 2.1. So there is one subtask which is used to filter the coffee, that is filter coffee simply means you need to have a paper here, which, so this is a container, the outside is the container, but inside you need to have a paper or a container for the coffee, which is going to allow the water to get down but not the coffee particles. Okay, so this needs to be a filter paper. All right. Okay, the next function, I think this is about it in something which is related to coffee. Okay, this needs to be manually, the coffee which is used up needs to be manually thrown out the filter paper along with the filter paper. Third one is hold the cup. This is the cup or the mug. A sub-function here 3.1 is to heat the cup. Okay. Next is the user input. So user input can be an on-off switch. So 4.1. This can be your on-off state. Switch. Okay. So remember, when we have in heat cup and filter and in heating water, you need power. Okay. So here 1.3 should be power supply, that is provide power input. So heat cup 3.2 can be power input. We are mentioning all of this because for each of the software input there needs to be, that is each of the logical function here, there needs to be a hardware, that is the switch, which will provide this function. So this list will help us also get the hardware, that is make the list of hardware. Okay, it will also create a mental picture about how the device needs to look like. Okay, what are the components it should have. So here the function is governing the physical shape of the device. Okay, partially. Obviously now you are open to creating the device. So the device can be something like this one. Okay, so one of the one shape is something like this, but there is nothing stopping us from creating a shape which is something like this one, right? We are able to create this also. This becomes our mug, and here there is this spout which is going to get the coffee out. Alright, so the components and the list of functions only partially govern the shape and the size of the device. The further specifications, that is when we move further to finding out the specifics, that is what will be the power of the coil, that is how fast you need the heating, how large the platform will be which will hold your cup, okay, and how large the coffee container will be. So till now we only have the list of functions, we do not have further specifics at this point. So that is what we will have to do next. Okay, finding out the specifics, the exact power. Now more and more the job of engineer we are getting to. The job of a designer, now they are calling these people designer who do the sketching stuff. Okay, something like this, that is a designer is somebody who shapes the device. So this looks more like an egg. Okay, and this machine also provides similar function, but both look completely different. So the job of a designer is to see about the aesthetics, the look and feel of the device, and the engineer's job is to locate the components inside and then fulfill the functions. Okay, so both of these should be done by one single person. In an ideal world this is going to be the case, but nobody has that much capacity that you can be good at both of these stuff, that is be excellent at sketching also and have the understanding of the ergonomic principles and all of that, and about the human mechanics, and study the user and all of that, and then also have the technical expertise of choosing a proper coil and designing the heat transfer system. So both of these, so the engineer and the sketch artist have to work together. That is what I like to call them, the sketch artist. We'll have to call both of these designer, that is either we call them sketch artist and an engineer, or we can call them the industrial designer and the engineering designer. So again, this is what I do not like. The job of engineering is somewhat underrated. Okay, so these are our functions. So this is an intuitive way of performing things like this. There is this black box analogy where since we do not know the shape and size of the object, okay, what we know is the output. So the function and the sub-function, the hardware for this is going to lie inside this black box, and what we know at this point is the output, and with our research we have found out what are the inputs needed to get this output. Okay, now further, this is the next step that is here. This is the next step that is coming down to a schematic, okay, a diagram. Coffee beans, water is the input, and then here they are keeping sugar and milk as supplementary material, although these things you can include from here also, that is then power source and the cup needs to be supplied, the container, and then what you're going to get out is, this is slightly more refining than the output and the inputs. Okay, the next level is this. Then further next level is this one, which is giving us how many components we need and what needs to be supplied to which component from outside. Okay, you need the power to be supplied here also, and you need the power. So in this case, this is a pressurized system where we are not having external, that is the heating source for the container. This is that diagram, but if we are going to design the manual, that is that kind of which we have just done, then we need to heat, that is supply power to the container also. Okay, so we can have the container here, somewhere here, that is place the container. Okay, this is our container, and then we need to supply the power there also. Okay, so this is like a flow chart which is telling us more than just the inputs and outputs. Okay, so how the things are handled, this is telling us the route of the coffee. Okay, the coffee needs to get in, then ground, then filtered, and then further it needs to come to a location where the water also comes and both need to mix. So this is telling us that we need a mixer here. This is our mixer. So this is telling us more than just the inputs and the outputs. Once we develop this, okay, the next step is by combining the mental picture which you have from your research about what coffee makers can look like. Okay, then these components details now which you have and the function details, you develop your first sketch. Okay, now it is not an easy job, it is really hard job. That is why you need two different people, that is the industrial designer and the mechanical engineer, to develop this. That is many more professionals are required. There may be many engineers, many marketing professionals, many designers, and further that is there are many departments which go into the design stage, the initial design stage, which is going to output these sketches. So since this is a concept development stage that we are talking about, we are not going to go deeper at this point into the morphological study. That is, what morphological study does is that in this case, for holding the water, okay, for heating the water, let's say this is your function for which you need the heated water, that is, you need heating of this water. For heating the water, you can have a coil, that is an inline coil. That is, here you are having a tube heater sort of mechanism. You can also have this plate heating mechanism, which is going to transport the heat. You have the same mechanism in an ironing machine, or in an iron. So you have in your iron the heating plate, okay, and the same heating plate here is existing here also in this concept. So you can have this also, an heating plate, or you could have an tube heater. So both of these will output different shapes for the machine. Now when you see from outside, obviously you can tell that both of these machines look similar, but some of the features are shaped by these components. Okay, so by having two different methods of solving one particular problem, that is heating water, you may have two different concepts. So you may have multiple, that is 5 or 6 methods of achieving one particular function, and for that the shape of the device might change. The shape and certain characteristics, that is the heating time for water, can change. Okay, so that is what is studied in a morphological study. Morph means shape. Okay, so morphological study means how the device is shaped based on your decision of the method by which you will solve a certain problem. So that we will see, the morphological study is seen as one more method which is added at the end of this stage, that is functional decomposition. Or you can directly, if you want to take a slight shortcut, that is if you are satisfied with this concept, or if you have slightly less time, or whatever your judgment is, your justification is, you can directly jump to drawing the concept itself after you have your function structure, that is this one. Okay, so by doing this research and functional decomposition and then function structure, all of these are combined to create our concept. You may develop many of these concepts and then go for concept selection. Again, for concept selection there are many methods which you can utilize. Okay, some of that we will see in our other lectures. So this is it for now. This lecture has extended a lot, so let's end this for now, and then we will see furthermore things down the line. That is, here you might have you have seen this. From need you're going for functional decomposition, that is, this is the product development cycle. After need you're going for decomposition, after that you're going for structure, then morphology, then from morphology you'll get concepts. You find out the specifics of concept by following certain engineering methods and calculations. You develop what are the components and what will be the specification of the components. After this we are going for the CAD design stage, and further that is this there are a lot of methods at a lot of stages, which of all of these we are going to cover, keep on talking about these things. So please do subscribe and stay in touch.